So we have some more rules for calculating derivatives without having to use the limit equation. Yay! Let's look at one. There is a rule called the product rule. And you would use it on an equation that looks like, or excuse me, a function that looks 3x minus 2x squared the square goes on the inside, times 5 plus 4x. And the product rule, let's make that a function. The product rule says that for a function that is a product, and in this case it is, right, we have a f of x, or let's say we have an h of x, and we have a g of x. If you have a function, if f of x equals h of x times g of x, then the rule to find the derivative is to take the first, h of x, and multiply it by the derivative of the second, and then add the second multiplied to the derivative of the first. So rather than working inside of this function for a second, let's go ahead and find these derivatives, the derivatives of the individual functions. So h of x, using the rules that we learned, the h prime of x that we learned last time, well, the derivative of 3x is just 3, and the derivative of negative 2x squared is negative 2 times, bring the 2 down, 4x to the 2 minus 1, which is just 1. And the g prime of x is, well, the derivative of a constant is 0, plus the derivative of 4x is just 4. So now we have a set of values that we can substitute into our power rule. So we are looking at the f prime of x equals h of x as it was originally, 3x minus 2x squared, times the derivative of g of x. So g prime of x was 4, plus g of x as it originally was, 5 plus 4x, times the h prime of x, which is 3 minus 4x. Now we have a little bit of algebra to do, but I think we can both agree, or all agree, that I don't want to put this through the limit formula, through the limit fraction. So let's just get at it. 3 times 4 is 12x. 4 times negative 2 is negative 8x squared, plus 5 times 3 is 15. 5 times negative 4, negative 20x. 4 times 3 plus 12x minus 4x would be 16x squared. So combine like terms, and let's see, negative 8x squared minus 16x squared is negative 24 x squared, and then 12x, take away 20x is negative 8x, plus 12x, so I just end up 12x, and 12x is 24x, take away 20 is 4x. It's crazy you can do all this work and the arithmetic will cripple you. And then 15, that's the only constant I have. And that's it. That's the product rule. So let's do an example using the product rule. Find the derivative of y equals 3x squared sine x. So, well, I could actually have this be 3 products, which would mean I'd do the product rule once and then do it again. But I think 3x squared, the polynomial, is pretty easy to find the derivative of. And I think sine x is easy, obviously, to find the derivative of. So if I took if I said that y equals h times k. Then I can say the h prime of x is 3 times 2 is 6. X to the 2 minus 1 is just to the first power. And the g prime, excuse me, the k prime of x, that's the sine function, is, we know this, is cosine of x. So now let's put it together. Y prime equals, first, 3x squared times the second, the derivative of the second, cos x, plus the second, sine x, times the derivative of the first, 6x. And let's see if we can make this prettier at all. So I have, well, I guess I could rearrange it a little bit. I have 3x squared cos x plus 6x sine x, and I think that's as good as it gets. Well, I guess I could factor out a 3x, so I get x cos x plus 2 sine x. So this is one of those cases where some teachers are going to care. They're going to want it in the factored form. Some are going to say it doesn't matter. I don't really care one way or the other. I can go back and forth, and I'm sure you can, between these two in my head. So if I'm expecting this answer and you give me this answer, I can totally see that, and vice versa. But if you like it, whichever way you like it is fine with me. All right, so let's look at the other rule. This is the quotient rule. Now the quotient rule is not easy. It's not. It's big, it's bulky, it's doable, but it sure beats the snot out of using the definition of derivative, the limit definition of a derivative, when you have a rational number. So we're just going to get over ourselves and we're going to do it. Okay, so if I have a function f of x and it's a result of some rational number h of x over k of x, then the derivative of f of x is, now I'm going to tell you how I know it. This is the way I say it to myself when I'm putting it together, and how I know it and how I do it. There is a thing, a little phrase that you can use. It's like up D, down D, bottom D, right D, whatever. If you look up the quotient rule on the internet, you'll find it. I cannot do it because I have already become ingrained in the way I do it. If you want to use the other method, you're welcome to do it, but you have to look at it. You have to look it up and just learn it on your own, and I'm never going to do it. It's exactly the same thing, except it's in sort of a reverse order when you build it. So that's a little advertising. I like my way. It works fine. If you want to learn another way where there's a little memory tool, feel free to do that. Either way is fine with me. So here's what I do. I'm going to use the word top, to talk about h of x, and I'm going to use the bottom to talk about k of x. Okay, so we want the derivative of the top, so that's h prime of x times the bottom as is, k of x, minus the derivative of the bottom times the top as is, all over the bottom squared. So now that I've written it out, I can actually tell you the little memory tool, which would not work for me. When you use the memory tool, now obviously I can't do this. I can't switch these because it's a minus sign and subtraction is not commutative. But it writes these two in an opposite order and these two in an opposite order. And it goes like this. Let me see if I can do it. So k is the bottom. It's the bottom d top minus the top d bottom over the bottom squared. So the bottom, k of t, is the denominator, and h prime is the top, so d top, the derivative of the top. and this is the derivative of the bottom and the top as is. So it's the bottom d top minus top d bottom over the bottom squared. Go for it if you want it. The important thing is that we get the job done. So let's do an example. I've got y equals 5x minus 2 over x squared plus 1. All right, so if I call h of x the top, then the h prime of x is 5, because the constant rule says this is 0, constant multiple rule says this is 5. The g prime of x, the bottom, is 2x plus 0. Okay, so I have all my parts. Now let's put it together. The y prime equals the derivative of the top, 5, times the bottom as is, x squared plus 1, minus the derivative of the bottom, 2x, times the top as is, all over the bottom squared. I will tell you, one of the selling points for my method is that it gives you your distribution from the front. Instead of having a 5 back here, you would have the 5 in front where it's easier. And if you're dyslexic like me, that matters. So let's figure out what this is. This equals 5x squared plus 5 minus, and be really careful here with the minus sign, 2x times 5x is 10x squared minus 2 times negative 2 is negative 4x over, well, I'm not going to distribute this yet, x squared plus 1 squared. I probably won't ever have to distribute it, or I probably won't, but if I need to, I can always do it later. I mean, expand it. So I have 5x squared plus 5 minus 10x squared plus 4x over x squared plus 1 all squared. So 5x squared minus 10x, that's minus 5x squared plus 4x plus 5 over x squared plus 1 squared. And I don't know if the top factors or not, but even if it does, I'm positive I'm not going to get an x squared plus 1, so that's crazy. Okay, so let's do another example, and this one will have a rewrite in it. So if I want to find, or I'm given, f of x equals 3 minus 1 over x all over x plus 5, and I want to find the value or the equation of the line for this one at the point negative 1, 1. All right, so I'm going to worry about the point, evaluating the point later. I'm going to at first just go through and find my derivative. Now, I could certainly do bottom d, top d. You know, I could use the quotient rule for this, but that would be a little bit crazy with this funny number in the numerator. So I'm going to go ahead and rewrite this as a fraction over a fraction, or common denominator, and then treat it like a fraction divided by a fraction. So I have 3x minus 1 over x times, now so this would be my denominator, times 1 over x plus 5, and that is 3x minus 1 over x squared plus 5x. Now it's much easier for me to take the derivative of, because I have the quotient rule. So the f prime of x equals the derivative of the top, so that's 3 times the bottom as is, x squared plus 5x, minus the derivative of the bottom, 2x plus 5, times the top as is, all over the bottom squared. Now, At this point in the game, I tend to just write d squared because it's the denominator squared, and then I don't have to carry this every step of the way like I did here where I just had to just keep writing it. That's kind of crazy, so I use a little shortcut. I just write d squared until I need it. So let's put it all together and kind of simplify. I have 3x squared plus 15x minus, and I'm going to keep my brackets for now, 2x times 3x, 6x squared, 2x times negative 1 minus 2x, 5 times 3, 15x, and then minus 5. I can change all the signs if I'm careful over my d squared, and then let's go ahead and combine things. Now I don't really have to worry anymore about the brackets because I changed all my signs. 3x squared minus 6x squared is negative 3x squared. 15x plus, oh look, 15x minus 15x is 0, so I get a 2x. And then I have a plus 5. And now I'll write my bottom in. X squared plus 5x squared. Now we want to finish out by writing the equation. So the f prime, this is the slope of my tangent line. So let's figure out what it is at, what was the point we were working with? Negative 1, 1. So I'm going to plug in the f of negative 1 equals, and I can just kind of put it together in my head. It's going to become positive, so no sign change. There's a sign change here, minus 2 plus 5 over, it'll become positive, so 1 minus 5, sign change here, I'll just write that part out. 1 minus 5 squared equals negative 3, negative 2, plus 5 equals 0. I just have to make sure that I haven't done something in the denominator that's not okay. 1 take away 5 is 4 squared, so I'm good to go. So my slope is 0 at this point. Now I'm going to write the equation of the line. So I know that I'm looking at 1, 1. So y minus 1 equals 0 times x minus x. Not that the plus or minus matters because it equals 0. And I could stop here, y minus 1 equals 0. But in this case, it's just as easy to write y equals 1. So let's head over to Desmos and have a look at what that means. I've already loaded up the function. This is what the graph looks like. You can almost see it over here. And right here at the point 1, 1, this is the lowest point of the graph. It's the turnaround point of the graph. So if I put in our tangent line, y equals 1, we can see just by looking that the tangent line to the graph right here is at the very, very bottom of the graph. If it wasn't at the bottom, the tan would have some kind of an angle to it. But there at the very bottom, it's come down, we're turning around at the very, very bottom, it has to go through 0. It would go from this kind of a line shaping this way to 0, and then it would start to be a negative slope pointing up this way. So from a positive slope to a negative slope, it has to go through a place that's 0. And that's the power of finding the derivative and then locating the place where the derivative equals 0. It's going to tell you your various turnaround points on a graph, which is really, really handy.